This is orb sign. It's 10E, problem number 17, where the expected readings of the following in the figure below. Ideal ammeter. Okay, so I've already gone through and labeled all of these and set up all the equations and answers we should get. And I'm just going to run through my process in doing so, because this would be a very long video if I didn't already do that. So before we even look at what we're asked to actually do, I'm just going to set up my the circuit the way I want to. So I drew the pink arrows in the direction of my current, and I based it off of this. And I based all the directions off of this power source. As you can see, if we go with the positive plate, we'll go this way, and then all the arrows that follow are just in reference to that initial direction. And then that will play a role, as you will see in my equations, because you'll see we'll go this way, and then as this pink arrow continues this way, we're actually going against current, so that will alter our sign in our Kirchhoff equation for that specific part. Other things to take away from this initial overview is when I was first doing this problem, I was very troubled initially doing my equations, because I had these. I had I3 and I1. I had them both labeled as the same thing to start, and as you will see, you will come to figure out that those two are equal, but it really confused me in making my diagram with them both initially labeled as I1. So I took a different path here. So I started out with I naught, as you can see, right after this battery that I kind of based my starting point off, and I broke it up into I1 and then I2 plus 3, and I would claim that I2 plus 3 is equal to I1. Or, well, yeah, okay, that's basically, yeah, okay. And then 2 I1s equal I naught. So it breaks off into I naught, and it continues up I naught, and it returns back, or I1, it returns back to I naught. That was one of my little squares I made. And then I went down to this, I2 plus 3. And then again, I had to break it off into I2 and then I3. As the current, would go its separate ways, even though it's against the battery. We're not worried about that yet. And it would meet up. What's that called? Junction rule. The junction rule. It would meet up, and it had to be equal to what came out. So the 3 would go down here, and then they'd meet up with the 2 again, and it would meet up with the 1 again, approaching the I naught, and we did a little circuit. This would look a little bit different if I would have chosen this as my main power source. I naught would be where I2 is. This I2 and 3 would actually be the same. This would probably be I1, and this would be I3, so it'd just be the same thing, but a little bit flipped. I still get the same answers. Maybe my sign would be a little different, because, that would be that. But, anyways, yeah, that's just the way I chose to set this problem up. And my problem told me that this second battery is 5.3. I highlighted it in white underneath, so yeah, this 5.3. And then the 7.4, it told me those were the resistances, and then I had to find every single current in here. I did have to find every single current. All I needed was I1, because that's all that would pass through the ammeter. But I had to set up multiple equations to, figure I1 out. And then this volt was probably the easiest way, and I'm not sure if I did it right, to be honest. But my reasoning behind it makes sense, to me at least. And it makes sense algebraically. So let's start off with part A. So ideal ammeter. So again, I'm going to start off with my Kirchhoff equations and breaking up the circuit into a couple smaller circuits. So my first grouping of letters would be A, D, E, H. And as you can see, let me just outline it real quick. That would be A, D, E, H. That would be this circuit up here. And I would start at A, work down to here, go down to here, and then go up to here, and then I'd return back to where I started. So A to D, there's really nothing going on. There's no resistance, and if we go back to our V equals IR. There's really nothing I can solve for here. And no Kirchhoff is I minus IR equals 0. Yeah, so there's really nothing I can use here because there's no resistor. But then at the bottom I do have my E3, my R value, which is 7.4. And you'll see that this is a negative sign while I am going with the current, I'm still needing, because I'm going with the current, I need to subtract. It's basically as if I'm coming off a battery. The first thing would be, it would take current off of that, or it would be a negative value if all of it were to go into there. And as I come back up, I can see I'm going against the arrows on this right side. As I go up, I'm going against the arrows at the end. So therefore, it's a positive value. And then that's how I, my reasoning that I was setting up earlier, that these I1 and I3 are the same, and this makes sense, as I said. I guess I was wrong when I said that I2 plus 3 is equal to I1, if this reasoning were to be correct. Because my thinking was, if I were to come off this battery, I would have to split here and here, and the same is true for here and here. And with all these arrows interacting with each other, what ended up shooting off this side up here must be equal to this side up here if the interaction were to be constant. The junction will prove this. But it just didn't make algebraically, as I was saying, my equations with my I1 initially and my I3, it just didn't really work for me in the sense that I kept confusing my variables, and I kept getting stuck at the same point. So once I finally chose to break them up into their separate but equal, components, then I started to be able to get equations going, and then it started to make more sense. And then my next circuit grouping would be ABGH. So I'll highlight that ABGH. So again, I'd start going down to A, nothing. Now I had a resistor here and a battery up here. So A to B, nothing. B to G, I had to be going against the current, so it should be positive, which is my 10. That's the 10 ohms from that resistor right there, times my I0 current, minus the 5.3, as I am going against the current of this battery, so I would have to subtract and I wouldn't add, and then plus my 7.4 as I am going against again. So here I would add resistance, but if I was going with current, I'd subtract, as I would be coming off a battery and all of the charge would be going into it. And then let's clean that up with my I0 equal to I1 plus I2 plus I3, as I explained, as it would break off into its components. And then substituting this I3 for an I1 because of the constancy I just found up here, the I1 equals I3. That's how I get my 28.6 I1 plus 10 I2, and I just clean up my volts is equal to 5.3 volts. And that's a necessity for, as you can probably see that sneaking there. And then my next little mini circuit would be C, D, E, F. So now we're on the opposite side down here. Let me just erase the highlights I just did. So now I'm on C, D, E, F. And if you notice on my arrows, I'm starting at the same spot on the left side going down. It's important to make sure your signs are constant, and you end up getting the correct answer at the end. So we see C to D, we have nothing, but then we have D to E, we are going with the current, so we should be subtracting here, so it'd be I3 times 7.4, or 7.4 times I3, and then we subtract again this 4.5 volts as we are going, I subtracted, right? Yeah, okay. As we are going, I'm trying to explain it in a way that, well, okay, let's say we started with it. Let's say, so it'd be 4.5 minus plus this 5.0 as we're going against this current that I have drawn, and then I would subtract this 7.4 times I3. So like, the way I wrote it down here is correct, but if I were to write it a better way next time, I would start with my with this battery here. So if I were to do it again, I'd probably write it like 4.5 minus plus, because we're going against the current, I2, 5, and then now we're going with it, so it's I3, 7.4. And there's nothing different about this one than the one I have down here. I accidentally drew a line through it. It's just the order. It helps to visualize what's actually going on a little bit better. And I clean that up to get 7.5 I1 minus 5 I2 equals 4.5 V, because I3 equals I1. And then I multiplied that bottom one by 2, so I can cancel out the I2s. So 43.4 I1 is equal to 14.3 volts. So my I1 is 0.339 amps. And that's for milliamps, that's why it's 339 milliamps as the answer. And the reason that is my answer is because, as you can see, I have labeled I1 is all that is passing through my ammeter. So all I need to know is I1. I don't have to worry about I2 plus I3 down here, because they're not passing through the ammeter. All I need is I1. So once I find I1, that's my answer. And then for my my voltage, look for a path to 200 voltmeter. Or shoot, that's what okay. Ideal voltmeter. Our answer should be 0.8. Now, the way I went about this was I started with my 5.3 volts. So I did 5.30 volts. And then I went with my current. I subtracted I naught. Well, actually, I wasn't even worried. So I just did IR, right? Minus my IR. Then with my current, kept going with my current, minus my another IR. Yes, I'd be minusing it because I'd be going against the current of that battery. So it'd be minus 4.5 volts. And this would equal 0. So basically my resistances would end up having to equal, or not my resistances, my currents times resistances would have to end up equaling this 0.8 volt value. So therefore 0.8 volts has to be what's on the voltmeter if that's what my stuff has to equal. And I guess a better way to just simply do this would just be subtracting your 5.3 from your 4.5, and this might take one, then depending on your current, maybe it's negative 0.8, but if it marks you wrong, just change the sign. But because in this sense it's going, there's going to be it's basically there's 5.3 volts going this way, but then there's 4.5 volts going this way. So in a sense it's almost like 5.3 this way, 4.5 this way. What's the net? The net would be 0.8 this way. And I'm not entirely sure if that's the correct way to go about this, but that's the way I end up doing it. And you might see here that, I just ask for the answers and work backwards. Well, I didn't even attempt this my first time around, so I'm pretty glad with the way I ended up coming up with the solution. I was actually trying to do 19 verse. I spent a couple days on that, and that just was not working for me. So this was kind of my final attempt at this problem. Challenges, again, just be labeling. When the first day that I tried, initially started with all my I3s equaling my I1, that made it pretty difficult for me, especially in the middle part where I would change it to I2 plus 3. So I could actually visualize the breaking apart of the current. It was a lot easier once I added that I3. And yeah, I might look around for the random voltmeter in there and an ammeter like, oh shoot, this doesn't look like the circuits I'm used to, or maybe they're just throwing me off a little bit with all these extra parts. Once you start drawing your currents, once you start drawing your direction you want to go and labeling your currents, and just following your rules that with the current subtracting against it you're adding in terms of resistances, you'll get there. It might not be the first time, but as long as you just try to keep figuring out, if you're doing something wrong, where you're going wrong, or what part you feel like you're messing up, you'll get there eventually.